A few days ago, I was watching a video on Mr. Carlson's lab in which he was working on a piece of Sansui audio equipment, and he brought out one of his hand-built secret weapons. It's called a signature analyzer, and his is built into an old oscilloscope. I think this is even a vacuum tube oscilloscope. I believe it's made by RCA. Yeah, RCA oscilloscope. And you may be able to see a little trace on the screen there. What he's doing is he's doing what's called signature analysis of a board. And he's doing that to try to find some drivers that are bad. But I'll let you watch that if you want to go over to Mr. Carlson's lab, which is a really good channel, and look at the Electronic Repair Sansui B77 Stereo Power Amplifier video. But this particular video sparked an interest in me in going back to something that I worked with many, many years ago, which were signature analyzers used in situations where, for example, you either didn't have a schematic or you needed to test the board or parts on a board without power being applied for whatever reason. And that's what this signature analyzer does. So then, just a day after I saw this, I got an email from SIG, and let me show you what they were talking about. SIG's email was offering, among a number of other items, some things for sale on what they call Cyber Week, which they do every year around Thanksgiving. And one of the items was this SIG101, and they had it on sale during Cyber Week for $104. Well, I figured the low price, the recommendation, or at least the impetus from Mr. Carlson, and the fact that I actually worked with some of these things many, many years ago caused me to say, why not? So I went ahead and bought it. And when it arrives, I'll open the box and go through all of the various features and so on. But I thought before I do, I might just tell you a little bit about why I wanted to get a signature analyzer. Now, this is more just a prop than anything else. It's a very old motherboard, but suppose that you're working on something like this, where you don't have a schematic. I don't think they ever, at least nobody I knew ever had schematics for motherboards, at least not outside the big service centers. And suppose that you're trying to figure out where a particular part is failing. Well, now, there are a bunch of software diagnostics you can use, built-in self-test cards that you can insert, post-test cards for the power-on self-test, and all those sorts of things. I'm not going to get into those. But the big thing is, suppose that you suspect that the problem is in a particular area, and it may be a part that you can change or fix. Now, I will tell you that one of the reasons that I stopped working on stuff like this was because, frankly, a lot of these little parts, let me slide this up a little bit and show you. A lot of parts like this are just almost impossible for someone like me to solder in a home shop. So while I used to work on stuff like this in my spare time and actually worked on TVs and other things in college, I haven't really worked on these since the 90s in terms of board level repair. But there are still times when a board will come along, as in the case of Mr. Carlson's lab, where he was looking for some LED drivers that were bad, where you'd like to test to see if you can figure out which is the bad component, but you have no schematic. All you maybe have is the data sheet for the particular device. And so, just as Mr. Carlson showed in his video, one way you can do it is to compare comparable pins on the same IC to each other. So suppose you have a device that has 4 or 6 or 8 outputs that are all exactly the same, and you suspect that one of them is bad. Well, one of the neat things about a signal tracer is, without having to apply power to the board, without needing a schematic, you can just go in and do a signature on each of the pins, and if one of them is different from the others, or maybe 2 are different from the others, that gives you a clue what is bad. More importantly, if you have multiple ICs of the same type on the same board, what you can do is compare each of those and thereby discover which is the bad component. For example, over here on this memory card, you could pull this memory card out and go through and test the outputs if you thought one of them was bad. Now, one of the issues, particularly with surface mount components like this, is even if you know which is the bad component, chances are it's easier to throw it away and buy a new motherboard than to try to find the replacement part, and especially if you don't have the specialized equipment you need for working on surface mount. But as we will hopefully see in a subsequent video, this also works for things like dual inline packaging, and perhaps we can do a video on using a signature analyzer to separate good parts from bad parts. At any rate, this is the sort of thing that prompted me to buy the SIG, or buy the Syscomp signature analyzer from SIG. So as soon as it arrives, I'll open the box and we'll take a look at it. So here's what comes in the box. I'm opening this for the first time. So it looks like a power supply, a stand for the unit, like a USB cable. And here is the unit. So let me get all this this wrap off of here and we'll take a look at it. Okay, we have the unit, the power supply with some adapters to adapt it to different styles of plugs. Looks like 4 different adapters and a stand, and a USB cable. So let's get it hooked up and see how it works. So here is the software loaded and running. I had previously downloaded the software in anticipation of the arrival of this unit. So I will tell you that it loads the software, installs that, and then it also installs the FTDI drivers. But when you plug in the SIG101 for the first time, it does go through the usual Windows loading drivers routine and then says system is ready for use. I will also tell you that when you first fire it up, it says the COM port is already in use, but if you click OK and then click on connect, it will connect, and you can see right up here this little flashing symbol says that it's connected. So that is kind of the unboxing and setup, and now we'll do a few experiments and see how this unit performs. I've been probing around on this board. By the way, this is an old Sound Blaster board, no longer needed in modern computers because they all have built-in sound cards. But I was probing around on it just because I do have a schematic for this particular Sound Blaster card, but I'm not going to be using it because the whole point of this is to see how useful this Syscomp signal or signature analyzer will be. Now, initially, I have done a few tests on a capacitor, a resistor, an inductor, a transistor, and an op-amp. I'm not going to show you those for this reason. First, there's a good video already on YouTube by SIG about the use of this unit on the capacitor and resistor. He didn't do the inductor, but it works too. But in my opinion, you shouldn't be buying this unit to test resistors, capacitors, and inductors. In fact, if you're going to do that, I suggest that you get something like this Atlas LCR meter. It's more accurate, it's easier to use, you don't have to set up a bunch of parameters and other things. But I am beginning to see that the signature analyzer will be useful in troubleshooting boards like this, particularly where you don't have a schematic and where, for whatever reason, you would rather test with the power turned off. So I'm going to show you a couple of signatures on this particular IC, on this particular board, just to show you how this unit works. But my opinion of this device is, I haven't tested the oscilloscope or the signal generator independently. They're both used in the signature analyzer, so in a way I'm testing them. But what I've concluded is that I would not buy this unit to use as an oscilloscope or a signal generator. But as a signature analyzer, I think it is a useful tool. And by the way, the reason I wouldn't buy it for the others is there are equally available alternatives for the same money or less that have more capability. But as a signature analyzer, I'm intrigued by this, and I definitely think it would be worthwhile for that. Now, depends on how much you pay for it. I think I told you I paid $104 for this during Cyber Week at Selig. But my understanding is the regular price on this is close to $400, and I'm not sure I would pay $400 for this. But for $100, I think it was definitely worth it as a signature analyzer, but not as a component analyzer. So let me set up and show you how I've been using this. I'll need to show you the screen. Oh, and by the way, just so you'll know what I'm doing, I have a BNC to banana connector attached to the connector that the signature analyzer uses, and then I have a pair of Pomona test probes that you may be able to, well, it's a little hard to see, there we are, that have some very sharp points that are plugged in. These are banana plugged to test probes, and the ground is hooked over there, so that I'll be able to probe these without shorting pins together. It helps to have a pair of probes like this with a really sharp point. It reduces the likelihood that you'll short a couple of pins together while doing this. Now, when you're testing this unit with power off, that's not a serious issue, because generally the amount of power this applies to the circuit is small enough that even if you short a couple of pins together, it's not a big issue. But I've just gotten used to, whenever I work on surface mount, I always make sure I have these really fine point test probes just to reduce the chances. So let's switch over, take a look at the screen, and I'll show you what I'm doing, and then I think I'll kind of wrap up this video for now. Okay, here's the screen again, and I'm not going to try to switch back and forth here. I'll just tell you what I'm doing. So the touching the pins, this is an NE, well, I don't really know what it is, but here is a pin. You notice that looks like a capacitor. The next pin looks like a junction. The next pin, whoops, can't look two places at once. It looks like a junction. The fourth pin, another junction, and the fifth pin, a junction. Now I'm going to go on and look at some more. I think this is actually a dual package. The first pin, nothing. Second pin, It looks like a junction, and looks like it's actually swinging both directions. Notice that there looks like a little Zener breakdown there. Now understand that there's nothing wrong with that. Zeners are supposed to break down. It just means that it's a conduction in the opposite direction from the normal diode action. The next one, the next to last pin, and then the last pin on that side. Okay, now, so what am I showing you? Well, up here are the four devices that it's designed to work with: resistor, capacitor, inductor, and diode. I find the diode position to be the one that, at least for me, works the best. For one thing, the diode position will also show you capacitors and inductors and other things, but it won't allow you to adjust the parameters. Let me give you an example. If you notice with the resistor, you have a test frequency of 500 hertz. With the capacitor, you can adjust things like the frequency and the offset. Let me move this over just a little so you can see all of that. And you see here that it's trying to measure resistance and capacitance. You go to an inductor and you have somewhat the same thing, where you can choose between parallel and series and so on. I'm not going to talk any more about these three because, like I say, the three videos on the SIG website or YouTube, SIG channel on YouTube, cover those pretty well in my opinion. So I've been using it in this diode position. And the nice thing about this over a homemade signature analyzer, which we could do, and maybe we might put one together with the analog discovery, because that's certainly something that can be done. But the nice thing about this one is that you can adjust the voltages with just a click of the mouse. So, for example, that's 2 volts from this position to this position. In other words, it's basically 1 volt per division. You can go to 1 volt from here to here, which is a ½ a volt per division, and notice now that the display stretches further out. You can also adjust the amplitude of the signal. Now, a homemade unit, you could do this too, but you'd have to go back into the software that controls the, for example, analog discovery, and make adjustments to the waveform generator and the oscilloscope and so on. The nice thing about this one is it's all right here in front of you. And similarly, you can do you can adjust the amplitude and also the offset. So right there, you may notice that, well, I guess it only offsets left to right. Did not realize that. Let's swap those. And you see there, that enables you. Now I think I should be able to. No, the offset still just works with the with one. Okay, well, I'm still learning how to use this, but my conclusion is that it is a usable signature analyzer, and that's what I intend to use it for troubleshooting primarily boards with the power off, where you can compare either one good board with a non-working board, or you can compare one working point on the circuit with other points, or just look at a bunch of points and see if any of them look out of place. For example, I mentioned Mr. Carlson using these to test for leakage in display drivers. That's one application where he didn't have a schematic, but he did have a pinout for the device that he was testing. And what he did was he just went down all the outputs, and a bunch of them all looked the same and a few did not. He replaced the chips where the outputs looked different, and it fixed the problem. So I used a signature analyzer many years ago, and I had pretty much the same experience. It won't fix everything. It won't even find all the problems. But it's a very useful additional tool. And maybe maybe I'll do a subsequent video at some point about the tools that I have found useful in the past for troubleshooting. One of the things that I noticed that new people to the field is many of them don't know about things like these signature analyzers that have been around for 30 or 40 years. Actually longer than that, because the octopus circuit, I think, goes back into the 40s or at least into the 50s. And I've done some videos on curve tracers using the octopus circuit. So has Alan at W2AEW, and of course Mr. Carlson has built one into his oscilloscope and so on. So these have been around for a long time, but sometimes people don't know what equipment is available and how it might be used so that they can make wise, or at least wiser, purchase decisions. Now, you don't need to go out and buy a whole lot of equipment, but it is useful to know, well, Mr. Carlson found this useful in this area, or Tom Tech Test used this in this way. So maybe I'll do a video on that, but for right now, I think what I'm going to do is declare the signature analyzer from Syscomp a success, at least for the intended purpose of testing TTL and CMOS and things of that sort, doing comparisons with the power off. So I hope you've enjoyed this and learned a little something from it. If you haven't seen a signature analyzer before, or if you're considering getting one, you might want to consider this one along with any others that you're interested in. But I think this is money well spent. I know I'm going to get a fair amount of use out of this in the future. So look forward to some more videos and have a nice day.